In this lecture, we continue the discussion on random variables. In the previous lecture, we were looking at this problem where we said that the customer has ordered 2 engines, and then we looked at a situation where there are 10 new engines and 2 old engines which have been added by mistake, and then we tried to find out what is the expected value, and we also found out what is the standard deviation of x. Now, let us continue the discussion by looking at properties of expected values, because we always have this question, what happens when we add or subtract a constant, what happens when we multiply, and so on. So, expected value of x plus or minus c, where c is a constant, is e of x, expected value of x, plus minus expected value of c. Now, c being a constant, its expected value will be c itself, and therefore, e of x plus or minus c is equal to e of x plus or minus c. One has to read this carefully. This is e of expected value of x plus or minus constant is equal to expected value of x plus or minus constant. For example, in the previous problem, what is the expected value after paying the initial shipping fee? That would be, if the shipping fee is 1000, then 33,007 minus 1000 is 32,007. Also, we have to remember that capital letters x represents a random variable, and lowercase letters generally indicate either constants or the values that the random variable can take. Therefore, you will always find p of x equal to x, capital X equal to small x. So, capital X is the random variable which takes a value small x. Now, what happens to the variance and standard deviation? So, variance of x plus minus c, which means when we add or subtract a constant, the variance does not change. So, it remains as variance of x. Similarly, standard deviation x plus minus c also will not change because the variance had not changed, and standard deviation of x plus or minus c is equal to standard deviation of x. If we multiply by a constant, then expected value of Cx, where c is the constant, is c times expected value of x. So, the expected value of x gets multiplied by c, whereas the left hand side, the expected value of multiplying every possible value that capital X can take by c. Now, standard deviation of Cx is equal to positive value or absolute value of c, because at times c can be negative. So, absolute value of c into standard deviation of x, and variance of Cx is equal to c square into variance of x. And since there is a square root involved, it will become standard deviation has to be positive, therefore, we take absolute value of c. Now, what happens when we have a combination of an addition and a multiplication? So, e of a plus bx is equal to a plus b times e of x. Now, that is a direct application of what we saw here and what we saw here. So, expected value of a plus bx is equal to a plus b times expected value of x. Standard deviation of a plus bx is equal to absolute value of b. Remember, the a will go, a being a constant will not have an effect in the variance and in standard deviation. So, a goes, only b is important and b can be negative. So, we also want to say here that we take the positive value of the b. So, absolute value of b into standard deviation of x, and variance of a plus bx will be b square into variance of x. We now look at this exercise where a and b play a game. A and b toss coins. If both are heads, that is, if both a and b toss heads, a wins rupees 200. If both are tails, b wins rupees 100, and if one is a head and one is a tail, no money is transacted. We also assume that a has a biased coin with a 60% probability of heads, while b has a fair coin with a 50% probability of heads. Find the expected value of a, expected value of b, and the variances. Now, this random variable, there are 3 outcomes. Both toss heads, one head one tail or one tail one head, and both toss tails. So, we look at this problem from A's perspective. So, gain for person A when both toss heads is 200 with a probability of 0.3, because A tossing a head is 0.6. The problem assumes that A has a biased coin, B has a fair coin with 0.5, therefore, both tossing heads is 0.6 into 0.5, which is 0.3. One head, one tail is A tossing a head 0.6, B tossing a tail 0.5, which gives us 0.3, A tossing a tail 0.4, B tossing a head 0.5, multiplication is 0.2. So, 0.3 plus 0.2 is 0.5, which is shown here. HT and TH is 0.5. HT is 0.3, TH is 0.2, and the total is 0.5. Both tossing tails, A tosses tail with 0.4, B tosses tail with 0.5, and therefore, both tossing tail is 0.4 into 0.5, which is 0.2, which is also given here. Now, the expected value is 200 into 0.3 plus 0 into 0.5 minus 100 into 0.2. So, 200 into 0.3 is 60, 0 into 0.5 is 0, minus 100 into 0.2 is minus 20, therefore, the expected value is 40. Now, this expected value is shown as mu equal to 40 here. So, we find the deviations x minus mu, 160, minus 40 and minus 140. Square values are shown 25,600, 1,600, 19,600. So, the variance is 25,600 into 0.3 plus 1,600 into 0.5 plus 19,600 into 0.2, which gives us 12,400, and standard deviation of A is square root of 12,400, positive square root, which is 111.36. Now, let us look at the problem from B's point of view and try to understand the relationship between the expected value of B and the variance of B versus expected value for A and the variance for A. Now, when we look at this from B's point of view, again the random variable takes 3 values with a difference that when both toss heads, B loses 200, therefore, B, the value that it takes for both heads is minus 200 with the same probability of 0.3. So, when A gains 200, B loses 200, therefore, we get minus 200 with 0.3, 0 with 0.5 and plus 100 with 0.2. Remember that for both tails, A lost 100, which is B's gain, and therefore, B gets plus 100. Now, the expected value of this random variable is minus 200 into 0.3 plus 0 into 0.5 plus 100 into 0.2, which is minus 40. Variance of B is, we find out the deviations. So, mu is shown here as minus 40. So, the x minus mu for the 3 outcomes are minus 200 minus 40, which is minus 160. Once again, minus 200 minus 40 is minus 160. 0 minus 40, 0 minus 40 is 40. 100 minus 40 is 140. Please note that mu is minus 40, and therefore, the calculations are shown like this. If you see carefully, in the previous case, the values were 160, minus 40 and minus 140. Here it is minus 160, 40 and 140. So, x minus mu square will be the same, because here you have negative, there you had a positive. So, 25,600, 1,600, 19,600. So, the variance is 25,600 into 0.3 plus 1,600 into 0.5 plus 19,600 into 0.2, which is 12,400, and the standard deviation is 111.36. So, up to this point we realize that expected value of B is the negative of the expected value of A, variance of B is the same, standard deviation of B is also the same. From the earlier relationships we saw that E of B is equal to C times E of A. Now, C is minus 1, because what is A's gain is B's loss, and what is A's loss is B's gain. Therefore, if E of A is 40, E of B is C times expected value of A minus 1 into 40, which is minus 40, which is what we computed here. Variance of B is C square into variance of A, where C is minus 1, C square is plus 1. So, variance of B is equal to variance of A, and we found out that both are 12,400. For A it is 12,400, for B also it is 12,400. Standard deviation of B is absolute value of C into standard deviation of A. Since C is minus 1, absolute value is plus 1. So, 1 into standard deviation of A, same 111.36, and both show the same value. Therefore, we have just shown and demonstrated this equation that E of B is equal to C times E of A, and variance is the same in this case, where C is minus 1, C square is plus 1. So, variance of B is C square into variance of A, and standard deviation of B is absolute value of C into standard deviation of A. Now, if we express B's numbers in paise, what happens to the mean and the variance? Now, expected value of B is rupees minus 40, which is minus 4,000 paise, and therefore, the three gains are minus 200 becomes minus 20,000, 0 stays as 0, and plus 100 becomes 10,000. So, x minus mu gets multiplied by 100. Earlier it was minus 160, 40 and plus 140. Now, it is minus 16,000 plus 4,000 and plus 14,000. The squares get multiplied by 100 into 100, which is 10,000. So, 256, 1, 2, 3, 4, 5 followed by 6 zeros, and 16 followed by 6 zeros, and 196 followed by 6 zeros. And therefore, the variance is 256, 0, 0, 0, 0, 0, 0 into 0.3 and so on. And when we do this, we get 124, 0, 0, 0, 0, 0, 0, which means the variance gets multiplied by 10,000 and the standard deviation gets multiplied by 100. The expected value also gets multiplied by 100. So, now we try to establish that relationship. So, expected value of B in paise is C times the normal E of B. Now, in this case C is 100. So, earlier expected value of B was minus 40, now it becomes minus 4,000, which we have calculated here, which we can also see as minus 20,000 into 0.3 plus 0 into 0.5 plus 10,000 into 0.2. So, variance of B in paise is equal to C square into variance of B in rupees. So, 12,400 becomes 12,400 into 10,000. So, since C is 100, C square is 10,000, it gets multiplied by 10,000. Standard deviation of B is equal to absolute value of C into standard deviation of B in rupees. So, standard deviation of B in paise is 100 times standard deviation of B in rupees, which is 111.36 into 100, which is 11,136. Now, let us look at another example to compare random numbers and understand this. So, let us take an imaginary situation where say we have to decide between England and India to host the next Cricket World Cup. Now, let us say there are 60 matches, the number of people attending matches and the probability are given. So, please note that this is an imaginary problem that we are trying to solve, and we are only trying to explain the methodology using this interesting imaginary situation. So, we would say that in England the expected people could be 10,000 or 20,000 or 30,000 attending a match, whereas in India it could be 30,000, 40,000, 60,000 attending a match, and with probabilities given as 0.2, 0.5 and 0.3. Let us assume the ticket cost about 600 in India and 30 pounds in England. Find the expected value, standard deviation and compare. So, let us say we do it in England. So, outcome 10,000 people attending with probability 0.2 and so on. So, expected value for the people attending is 10,000 into 0.2 plus 20,000 into 0.5 plus 30,000 into 0.3, and the expected value is 21,000. Now, deviations are also given. So, minus 11,000, minus 1,000 and 9,000. So, we find the variance and we find the standard deviation. Now, for the same thing done in India, 30,000 with a probability 0.2 and so on. So, expected value is 44,000 and the variance and standard deviation are bigger figures. So, now if we look at place 1, which is England, and then the expected value is 21,000, variance are given, and let us say we also try to convert the whole thing is in pounds. So, standard deviation is 1626663. Now, in India, so we multiply by the money, and therefore, when we multiply by the money we get this in pounds, which is given here and this is given here. So, 21,000 people 378,000 pounds and so on with the variance and standard deviation are given here. Now, for India we convert it into rupees, we use that 6,000. So, the variance and standard deviation figures are given here in rupees, and then we convert $1 equal to 0.72 pounds and $1 is 68.67 rupees to make a comparison in a third currency, just to understand the idea of multiplying. And then we realize that for England expected value is $525,000 and standard deviation with a coefficient of variation of 0.043. In India the coefficient of variation is 0.0644, and therefore, we can try to choose the place that has a lower coefficient of variation. So, that way this example helps us to understand the multiplication, the comparisons, the change in currency and so on. So, while the number of people attending was the random variable that was later converted to the money generated. So, all these can be done and decisions can be made against a common denomination, and that is what this example essentially tells us. Now, let us continue this with a discussion on the random variables. So, we begin with a simple match the following example. So, there are 6 items, expected value of x takes mu, which is here. So, which is given by this, expected value of x is mu, variance of x is the expected value of x minus mu the whole square, expected value of x minus mu will be 0, 10 times standard deviation of x is 10x if x is the standard deviation, probability of capital X equal to small x is p of x, and standard deviation of x is the root of the variance of x. So, that is how we match and try to understand the relationship between the items in column A and the items in column B. Now, let us look at this. The random variable x represents the salary of a girl MBA student, while the random variable y represents the salary of a male MBA student. There are 10 girls and 40 boys in the MBA class. If the mean of y is 10 lakhs, the variance is greater than 10 lakhs. Need not be true at all. We could have a situation where the y is actually the salary of the male. So, we could have a situation where the variance is greater than 10, and we could have a situation where the variance is less than 10. If expected value of x is 12 lakhs, then p of x less than 12 is half, need not be, probability of x taking a value of 12 is half, need not be again. The unit of standard deviation of x is rupees, could be true because the salary right now has been given in terms of lakhs of rupees. So, we can convert it to rupees and then measure the standard deviation of x in rupees. If the highest salary is 20 lakhs, then E of x and E of y should be less than 20 lakhs. We could say true. The only case that will happen is all of them have the same 20 lakhs, in which case they will be equal to 20 lakhs. So, we can generalize it and say E of x and E of y should be less than or equal to 20 lakhs is true. If the salary increases by 10% for everybody, E of y should also increase by 10%. Yes, E of y would also increase by 10%. Now, we look at another question. A game is as follows. You are given a number between 1 and 6 and you roll a die. You win rupees 6 if the die rolls the number that is with you. Otherwise, you lose the entry fee of rupees 2. What is the expected value of the return? Is it a fair game? So, probability of win is 1 by 6 because you have a number, the die can roll any one of the 6 numbers. So, probability that the die rolls the number that is with you is 1 by 6. So, you win with a probability of 1 by 6 and you lose with a probability of 5 by 6. So, expected value is 6 into 1 by 6, I get 6 rupees if I win. So, 6 into 1 by 6 and I lose 2 rupees. So, minus 2 into 5 by 6, which is minus 2 by 3. Of course, one can argue that when I win, I actually have an entry fee of 2, therefore, my gain is only 4, but right now we use 6 into 1 by 6. Let us assume 6 is the gain, which also means that you get 6 rupees more than the entry fee. So, 6 into 1 by 6 minus 2 into 5 by 6, which is minus 2 by 3. So, in a fair game the expected return is 0 and therefore, this game is not a fair game. Now, a random variable has mean mu equal to 100 and standard deviation sigma equal to 20. Find the mean and standard deviation of the following random variables defined from x. X plus 20. So, x plus 20, the mean changes from 100 to 120, the standard deviation remains at 20 and does not change. X by 2, the expected value also becomes half, which is 50, standard deviation becomes half, which is 10. 3x minus 10, expected value will be 3 times 100, 300 minus 10, 290. The minus 10 does not have an effect on the standard deviation, therefore, it will be only multiplied by 3, which is 60. X minus x, so mean is 0 and standard deviation also will be 0. Investor buys stocks of 2 companies spending 10,000 in each. The stock of each company goes up by 50% with a probability of 0.6 or goes down by 40% with a probability of 0.4. So, let the random variable x represent the value after 1 month. So, both increase by 50%, x is 30,000, probability 0.36. One increases and the other decreases, x is 21,000, probability of x is 0.48 and both decrease, probability is 0.16. So, expected value is 22,800, standard deviation is 6235.4. So, with this we come to the end of our discussion on random variables and we will continue our discussion on models on probability in the next lecture.